Hello, friends, and welcome. Have you ever stopped to think that every single thing around you has a secret? Just look, the glass on your table, the tallest building you can see outside, believe it or not, they all have a hidden rhythm, a secret beat. Today, we're going to uncover that secret and dive into the fascinating world of natural frequency.
So, let me ask you something. When you pluck a guitar string, why does it produce that one specific musical note? Why not just some random, messy noise? Or what about a simple pendulum? How does it keep such a steady, predictable swing, back and forth? Well, the answer to both these things is exactly the same, and it's a really fundamental principle of physics.
And you know what? Once you start looking for it, you'll see this principle absolutely everywhere. I'm not joking. Think about a child on a swing, settling into their own comfortable rhythm. Or a tuning fork. You strike it and it sings with that one pure, constant tone. And yes, even that legendary feat of an opera singer shattering a glass with just their voice, all of these things are happening because of one single concept, an object's natural frequency.
Okay, so let's get right into it then. What exactly is this natural frequency? Well, the simplest way to think of it is as an object's own unique internal rhythm. It's special rhythm.
Now, the formal definition might sound a little bit, technical, but trust me, the idea is very simple. When disturbed just means you give it a little push or a tap. The key part is vibrating freely, meaning you're not pushing it anymore, you're just letting it do its own thing. That one single frequency it settles into all by itself. That, my friends, is its natural frequency.
But here's where things get really, really interesting. What happens when an outside force, an external rhythm, starts to match that special internal rhythm? Well, something incredibly powerful happens. And this phenomenon has a name.
And that massive effect is called resonance. It's what happens when an external force's vibrations perfectly match an object's own natural frequency. Let's go back to our example of the child on the swing. We've all done this, right? If you time your pushes to perfectly match the rhythm of the swing, with just a little bit of effort, they go higher and higher and higher. That is resonance in action, right there.
But this power can also be very, very destructive. For engineers designing massive bridges or tall skyscrapers, ignoring natural frequency it can be catastrophic. Seriously. If vibrations from something as simple as the wind just happen to match a bridge's natural frequency, resonance can build up those vibrations so much that the entire structure collapses. It has actually happened.
So you might be wondering then, what determines this frequency? What decides this special rhythm for every object? Well, the science behind it is surprisingly simple, and it really just comes down to two key factors.
Okay, don't get scared. I'm showing you a formula, but I promise there's no maths test today. We're just going to focus on two letters here. You see them? K and M. They tell us the whole story, everything we need to know.
It all comes down to two simple things. K, which stands for stiffness, and M, which stands for mass. Stiffness is just how rigid or stiff an object is, and mass is basically how heavy it is, and the relationship is very intuitive, Yar. Think about it. The stiffer something is, the faster and higher it's going to vibrate. The heavier it is, the slower and lower it's going to vibrate. That is exactly why a short, tight guitar string gives you a high note and a long, loose one gives you a low note. It's that simple.
So, after all of this, what's the one big idea you should take away from our little discussion today? Well, for me, the best way to really understand natural frequency is with a simple but very powerful analogy.
This, for me, is the most beautiful way to think about it. Every single object has its own unique heartbeat. A small glass bell has a very different heartbeat from a huge church bell, doesn't it? A steel beam has a different heartbeat from a wooden one, and by understanding this heartbeat, we can design safer buildings, create beautiful musical instruments, and really, we can truly start to understand the hidden rhythms that govern our entire world.
And this principle goes so far beyond just bridges and music. It appears in electronics, in chemistry, even in the orbits of planets. So it leaves us with a really big question, doesn't it? What other hidden rhythms are out there, governing our world that we're only just beginning to understand? So if you found this explanation useful, please do me a favor and hit that like button. And be sure to subscribe for more explainers just like this one. Oh, and share it with anyone who you think might find it interesting. Thank you so much for watching, and I will see you in the next one.